The very atmosphere possesses invisible scissors, capable of violently tearing apart weather systems. These unseen forces create conditions so extreme they can flatten structures and reshape landscapes in mere moments. Understanding these atmospheric shears unlocks secrets to some of Earth's most destructive weather phenomena. Atmospheric science reveals a complex, dynamic fluid ocean perpetually swirling above our heads. Within this ocean, air masses move at varying speeds and in different directions across vertical layers. This differential movement, where wind speed or direction changes rapidly with height, is known as wind shear. Imagine trying to cut paper with scissors, where one blade moves much faster than the other. That uneven, conflicting motion perfectly illustrates the disruptive power of atmospheric wind shear. This invisible atmospheric cutting action dictates the birth, life, and death of many weather events. It provides the foundational energy needed to organize powerful thunderstorms and even spawn deadly tornadoes. Without this specific atmospheric ingredient, many of the most intense storms would simply fizzle out harmlessly. Therefore, grasping the mechanics of wind shear is absolutely critical for understanding Earth's volatile climate. This fundamental concept explains why some storms become monstrous while others remain comparatively weak. Wind shear manifests in two primary forms: directional shear and speed shear, each with distinct effects. Directional shear occurs when winds shift their direction significantly as altitude increases, perhaps from south to west. Speed shear, conversely, involves a rapid increase in wind velocity with height, regardless of direction. Both types of shear introduce rotational motion into the atmosphere, like an invisible rolling pin. This horizontal rotation, often called vorticity, is initially invisible to the naked eye, but that horizontal spin can become deadly when encountering a powerful, rising column of air. Imagine a horizontally spinning cylinder of air being stretched upward by a strong thunderstorm updraft. As this cylinder stretches vertically, the principle of conservation of angular momentum takes hold. Just like a figure skater pulling in their arms to spin faster, the rotating air accelerates dramatically. This upward-stretched, rapidly spinning column within a thunderstorm is called a mesocyclone, the heart of supercells. Mesocyclones can be miles wide and extend through much of the storm's vertical height, churning violently. Intriguingly, not every mesocyclone produces a tornado, leaving scientists with enduring questions about the precise trigger. The exact mechanism for tornado genesis from a mesocyclone involves further complex interactions near the ground. Scientists believe that downdrafts wrapping around the mesocyclone can concentrate its rotation even further. This concentrated rotation then tightens near the surface, forming the visible funnel cloud we recognize as a tornado. These powerful wind shears can also destabilize jet streams, causing them to meander more dramatically across continents. Such disruptions influence large-scale weather patterns, steering entire storm systems and shaping regional climates. Yet the destructive power of wind shear extends far beyond just rotational storms like tornadoes. Consider mountain ranges. Winds flowing over them encounter extreme shear, creating dangerous turbulence for aircraft. This mechanical turbulence can violently jostle planes, creating a sensation like hitting an invisible wall. Similarly, strong wind shear near the surface can create microbursts, sudden powerful downdrafts that spread outward. These microbursts mimic small, localized bombs, producing damage equivalent to a weak tornado, but without rotation. They represent another dangerous manifestation of conflicting wind forces, able to cause significant localized destruction. Understanding the nuances of wind shear helps meteorologists predict the type of severe weather likely to develop. Is it a supercell with tornado potential, or perhaps a squall line, producing widespread damaging straight-line winds? The atmospheric scissors determine the answer, sculpting the skies into either benign or catastrophic forms. This intricate atmospheric ballet of conflicting winds continuously shapes our planet's most dramatic weather events. Yet, even with advanced models, predicting the precise moment these shears will ignite a major event remains challenging. Predicting the precise moment these shears will ignite a sea, infrastructure, and the natural world.
For aviation, sudden encounters with strong shear can lead to dangerous loss of lift, especially during takeoff and landing.
Pilots sudden undergo extensive training to encounters with recognize and strong mitigate the shear can lead to dangerous threats, loss of lift, posed by these invisible atmospheric blades. On the ground, Communities face devastating consequences from tornadoes and microbursts, fueled by intense shear. Homes are leveled, trees are uprooted, and entire neighborhoods can be irrevocably altered in mere minutes. Farmers, too, contend with the unpredictable nature of shear-driven storms, which can wipe out crops instantaneously. The economic costs associated with repairing damage from these severe weather events run into billions annually worldwide. Beyond immediate destruction, the long-term psychological toll on affected populations can be immense and lasting. Meteorologists constantly monitor wind shear data from weather balloons, radar, and satellite observations. Measures this crucial information helps issue timely warnings, providing precious minutes for people to seek shelter and prepare.
Improved understanding of shear dynamics directly translates into more accurate forecasts and better public safety measures.
Scientific advancements continue to refine our ability to predict where and when these atmospheric scissors will strike. Protecting lives and property hinges significantly on our ongoing quest to unravel wind shear's complex secrets. Truly, these invisible atmospheric forces hold immense power to shape our world in both subtle and spectacular ways. Ultimately, wind shear acts as the atmospheric architect, sculpting both life-giving rain and destructive storms. This fundamental force demonstrates the intricate, powerful dynamics constantly at play within Earth's atmosphere. From shaping clouds to fueling supercells, these invisible shears are vital components of our planet's weather engine. The complex interplay of wind speeds and directions continually crafts the very sky above us. If you found this explanation fascinating, please subscribe for more incredible insights into Earth's amazing sciences. Share your thoughts in the comments below about which atmospheric phenomena you find most captivating.